So this is a TYS question. 2019. No. Also at the same time, it's good for me to give you a revision on thermodynamics formula. So can you tell me, when it comes to doing questions like this, like what are the relevant formula to keep in mind as you're doing the question? Okay, and what would that be?
NP, PDR.
So when do you use this? The first one? So when this is based on number of particles, and this one will be, yeah. Okay, any other formula?
One third. And what means it means square.
Mean square. Mean square speed. Okay. So use this only when you're required to find speed. Something related to speed and the PBs.
We did everything so to find key. Sure, we'll do anything.
Yeah. Okay.
Then we could that was changing from that was the key changing volume.
Change in work done. Yeah. Rate of work done. Or change in work done. Sure. There must be a negative for this one. If you are dealing with what? A bit on work done on the gas. Must be a negative.
thermal energy equals to heat supplied to gas plus work done.
And the internal energy is what? Is that direction? Increase. Increase in internal energy. There must be a direction for each of them. Yeah. I mean, by direction, I mean, is it increasing or decreasing? So increasing, supply, work done on. Each of them has a certain direction, and I don't mean that in terms of vector, but in scalar. Is it going up or is it going down? Is it increasing or decreasing? Is it supplied or removed? Is it work done on or is it work done by the gas?
And U equals QB plus P.
Okay. So for ideal gas, do we need to consider P?
Yes.
Yeah. All right. Very good.
So we don't have to work.
Ideal gas, when you assume something is ideal, there is negligible intermolecular forces of attraction. So there wouldn't be P. Now, when you see a graph like this that has actual numbers, what should be in your mind? I told you before. There's another formula that should also be in your mind.
Equals the area of
Okay.
the axis.
And is the volume lah. For example, you got some work done here, and also there's work done here as well. Any other things? Got numbers one. Something like a P and a V. Hmm? Mm, okay, it's something related to the internal energy. The internal energy at every point can be found by what? 302 PV. So each of the points here, you can find the U. You can actually find UA, UB, and UC. And let's say, right, they ask you to find change from UA to B. It's just UB minus UA, which will become 302 P, PB, VB minus PAB. Then because of that, right, you can actually find, you can link back to this one. 302 NK delta T. You can find the change in temperature, provided you know the N and the Ks. And K you know, Boltzmann constant, provided you know the N. So why am I putting this out is because like what we did for gravitation, right? You need to know all the formula, and this is the formula. It's good that you mentioned quite a bit of the stuff on your own, which is a good thing. But take note that this one is very, very useful.
I think that's all.
Yeah.
We have K equals to Sherman board and K. Actually, K can be replaced by K.
Yeah. Yes, can. Actually, yeah, it came from here. So 302 PV. PV equals NKT. You're right. Okay. So then from here, because you mentioned that the graph, you tend to get some questions wrong. So the right strategy is to write everything down and then use what you think you need to do the question. If you keep it all in your head and you don't write it down, right, then it's difficult to pick out the formula straight away. This is the formula, this equation that I need. It's difficult. Okay, for the gas at point P, at point B, calculate its temperature. Point B is here. What do you think you can do?
And see the volume and pressure.
So do you have pressure? Pressure is given, right? Over here. Um, I'm going to use a different ink so that it's easier to see. So it's halfway mark here. Somewhere, okay. I'm only telling you how to do the question. Punching in the numbers is easy, lah. So focus on the method.
Mhm.
Then this VB. So PB VB equals to NKT. Um, but you don't know NK, you see. So how?
Quite easy. Fine.
Yeah, you have VA, you have PA, you have TA.
Then we submit.
You can actually keep everything to one side. So PBVB over TB equals to NK. And this is a constant. which will then be equal to what? Related to A. Yeah, PA, VA, TA. So you know all of this, ma? Constant pressure, right? Can cancel liao. Then you can solve lah. You know VB, you know VA, you know TA, and then you can find TB. External work done by the gas. By the gas, so when you see this, WB is equals to W on negative. So you must take note, because everything you see here is, then the equation that you have here is all W on. So what do you do?
Find W1
From A to B. Quite straightforward lah. It's rectangle lah. Okay, so this is expansion. So W1 is already negative because it's expansion.
Yeah.
So negative of the area lah, that you find. For W on, expansion is negative, compression is positive.
Okay.
Yeah. So you get negative of the area, which the W bar is positive of the area. And that's how you get the answer. Okay. Now let's take a look at this. Every statement here got something on. All right. Let's take a look at the first statement. The temperature remains constant. What does it tell you?
It's so very
Isobaric. Sure. Isobaric is not volume. Isobaric is pressure. Yeah. No, baric is it comes from bar. Bar is pressure. There's a unit of pressure which is bar. Pascal is an SI unit, but pressure has different units.
Okay, that's so very volume is what? Isothermal.
Yeah. Then it's isothermal.
So the behavior in that process has
Yeah. What can you tell me about the U? The change in U? Why is it zero?
the temperature is
So the delta theta will be zero, and therefore the U will be zero. Why is that so? Because internal energy of a gas is mostly 100% kinetic if it's ideal gas.
very clean is proportional to the temperature.
Yeah.
So if temperature don't change, then T don't change.
So can you tell me what's the answer for this? Yeah. Okay. The gas now returns from C to A. During this change, the gas loses 2520. So what is this related to?
Um,
So the QE is what? Yeah. And so if we need to find the increase in internal energy, what formula do we use?
QE plus W.
And do we have a QE?
Yeah.
Yes. Do we have a W on? C to A. How do we know it's zero? There's no volume, so no change in volume. So it's zero. So what is the C to A answer?
Um, okay. Okay.
Yeah, so some students will forget to put that.
I remember the math is a bit wrong.
Yeah. What about A to B now?
It could be
A to B.
constant pressure. Hmm. I can calculate work done.
You can.
And all the
There are actually two methods.
we can get
Okay.
and then we create.
Okay. So tell me.
So the cycle right from me to see then to eight then to be again is the visible. Then you can put in the values. Zero and minus and 5 and plus you see it you
You need to find UAB now.
there you be
Yeah, there's one way lah. I think there are three ways lah. So this is way number one.
um
Way number two is A to B, right? So you got this lah. That's A to B lah. So find the PV values, the product, PV values, and you minus off downstream root 2. The third way is the longer way, which is you know, oh, another way is this lah. You know the temperature lah. So 302 NK delta T. You know the TB and the TA. Then you can find it. Yeah. I don't think you can use first law because you don't have your QE. Yeah, so you only left with three ways. So actually, right, this kind of question is quite okay. Many ways to solve. The whole point of running through you this is not only to share with you about the different formula that you need to apply, but also understand that there are more than one ways to get to the answer. Yeah. As we bounce around the logic, right, actually can approach from here, approach from there. So explore, lah. Don't be afraid to explore. I mean, the WAs are coming and probably don't have time to explore right now. But as you have more time alone after that, explore. If you get wrong answer, find out why you get wrong. Yeah. You learn when you explore. You learn when you get wrong. Okay? So this is quite a good question to go through. This is the one that they're saying. Oh, oh no, it's a different one. The graph one. But I've seen something similar before lah. Okay, continue working on other stuff.